Okay, so welcome to section 6.3, the pH scale. pH scale. And remember the last section was termed logarithmic scale, and that's because it has to do with the same similar types of scale, and we'll see in a moment. So note, the pH scale, or the pH of a substance. So the pH of a substance, and notice how I'm writing it, little p, capital H, substance, measures the concentration of hydrogen ions. So measures the concentration of hydrogen ions, denoted by a bracket, square bracket with a capital H and a plus, and then end square bracket, and is measured from 0 to 14. Is measured from 0 to 14. 0 to 14. Okay, so let's see, we have, 0 here. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so this is 14 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So what we have, let me do this, color code this correctly. So on the left, 0 is the most acidic. So most acidic. In the middle at 7, we have neutral. Then at the top, let's use orange, I guess. Or maybe I should use blue. What color? Maybe yellow, how about that? So here at 14 would be the most basic. So most basic or alkaline. Okay, so yeah, I use the term acidic and alkaline. So acidic would be here. Anything to the left of neutral. Between 0 and 7. And then alkaline would be anything to the right of neutral. Like lye or something to make soap with, which really burns. Okay, so let's see if we can give examples of things you might have seen. So for example, so determine whether the following are acidic, alkaline, or neutral. So determine whether the following are acidic, alkaline, or neutral. Okay, so number 1, let's say we have sauerkraut. A pH from 3.3 to 3.6. Okay, so that's clearly in the acidic range. Agreed? Acidic. Okay. So, of course, sauerkraut is cabbage, but it's been fermented. So just regular cabbage has a pH from 5.2 to about 6.8. Okay, so that's still a bit acidic, but a little bit less so. It's almost neutral, right? So acidic, but not as acidic. Okay. So number 3. So we have broccoli, which has a pH from about 6.3 to 6.85. So once again, that's acidic, but not terribly, right? Let's see, maybe I should have done this one in I did not. Why didn't that work? Oops. So I want the style of this to be the darker orange so that I can use the lighter orange for broccoli. So this is acidic, once again, almost neutral, right? So number 4. Let's say we have collard greens. With a pH from 6.5 to 7.5. Okay, well that's right at neutral, so I'm going to call that neutral, approximately neutral. Okay. Let's do number 5. Let's say toothpaste. So toothpaste has a pH of about 9. Okay, so if I look at that, that's definitely in the alkaline range. So alkaline. And then, of course, the most alkaline thing we can possibly get is bleach. So bleach has a pH of about 13. So that's exceptionally alkaline. So I guess I could do alkaline, but you can't see that because I can't see that. Okay, so I guess, what should I do? What color should I use? I guess I'll just do alkaline. Okay. And by the way, pure water is neutral, just in case you didn't know that. So note, the pH scale, hence the word scale again, much like logarithms, the pH scale is logarithmic. So definition. Okay, so the pH is the exponent in the equation. So is the exponent in the equation hydrogen concentration, capital H plus inside of brackets, is equal to 10 raised to the negative pH. Okay, so note the pH is always positive, right? But the exponent is negative in this equation, right? Okay, so what do I mean about that? Well, let's consider how would I change this from exponential form to logarithmic form. So let's consider I'm going to write this in a specific manner. Hydrogen concentration is equal to 10 raised to the negative. Maybe I should do that negative in a different color. What color? Pardon me. Negative pH. Okay, so if I wanted to translate this into the logarithmic form, I would have log base 10, which is common logarithm. It would be raised to the negative pH, and the argument would be the hydrogen concentration, H plus. Okay, but I want to solve for pH. So I'm going to do two things at once. I'm going to put the negative on the other side of the equation, which I can do. So pH is going to be negative. So the negative of common log, which means I don't need to write the base 10 because it's common log of the hydrogen concentration, H plus. So remember, I can get rid of the base 10. So because base equals 10, it's common. I don't need to write it. Okay. So for example, let's find the pH for the following. So find the pH for the following hydrogen concentrations. Following hydrogen concentrations. So number one, let's say I have a hydrogen concentration equals to 0.00001. Okay, so how many zeros is that? Well, that's really 10 to the negative. Actually, maybe I should do the negative. Maybe I should, I'm going to try and keep the color code the same. Okay. So this is 10 to the negative in green, and my exponent is going to be 1, 2, 3, 4, 5 zeros. Remember, we count the 0 preceding the decimal when we're going backwards. So this means that my pH, which is the exponent here, is positive 5, right? And note that that's positive 5 is acidic, right? So I can say this is acidic. Okay, so let's do another one. So number 2, let's go down here. Let's say I have a hydrogen concentration of 0.001. Okay, so once again, I have 3 zeros preceding the 1, and since it's a decimal, I know it's negative 3. Okay, but remember the pH is the positive there, so the pH is going to be positive 3, which once again is acidic. So number 3, let's say I have a hydrogen concentration of 0.000000000. 0, 0, 1. Okay. So this should be 10 to the negative. How many zeros do I have there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the minus 9. Okay, so my concentration is 10 to the minus 9, which means my pH is 9. And of course that means that I'm alkaline, right? Anything above 7, alkaline. Or basic. Okay, let's do another one. Example. So what hydrogen concentration yields a pH of the following? Okay, so number 1, let's say the pH is equal to 7. Well, that must mean that my hydrogen concentration is equal to 10 to the negative 7, right? Because the pH is the exponent that's positive. So 10 to the minus 7 is a hydrogen concentration that yields a pH of 7. So let's say now the pH is 13. So the hydrogen concentration is going to be 10 to the negative, and this would be 13, right? Because the pH is the exponent without the negative. Okay, another one. Let's say you've got a pH of, 2. So in that case, the hydrogen concentration is 10 to the negative. And of course, negative pH, that's negative 2. There we are. Okay, so I'll see you guys in the next section and chapter.